let's look at the equations for horizontal and vertical lines. So here we have our Cartesian plane with our y-axis and our x-axis. And here we have a horizontal line. Now it's parallel to the x-axis. And let's look at some of the points on this line. If we look at this point over here, the x value is 1 and the y value is 3. If we look at another point over here, the x value here would be positive 3 and the y value would be positive 3 as well. If we chose one on this side, the x value would be negative 2 and the y value would be 3. If we chose another point over here, the x value would be negative 4 and the y value would be positive 3. So hopefully you're seeing the pattern here. It doesn't matter really what the x value is. Our y value is always this number 3. So this line can be described as the line where y is always equal to 3. Let's try another one. If I draw a horizontal line there, it's also parallel to the x-axis. Let's look at some of the points. If I choose this one here, the x value is 2 and the y value is negative 2. If I choose a point here, the x value is 5 and the y value is negative 2. If we look at the negative side, the x value is negative 1 and the y value is negative 2. One last point, this x value is negative 3 and the y value is negative 2. So on this horizontal line, it doesn't really matter what happens with the x. The y value is always negative 2. So we can just say, well, this line is the line where y is always equal to negative 2. So a horizontal line always has y equals a number, and that number is the number that it crosses through on the y-axis. So the y-intercept, where it crosses through the y-axis, is at positive 3, and we can see that y equals positive 3. With this horizontal line here, it crosses through the y-axis at minus 2. We call that the y-intercept. It intercepts with the y-axis at negative 2. And this line can be described where y is always equal to minus 2. So that's horizontal lines. Let's look now at what happens with vertical lines. Now a vertical line is going to be parallel to the y-axis. So if we draw a line there, parallel to the y-axis, let's look at some of the points on that line. If we choose this one here, the x value is 2 and the y value is 5. If we choose another point down here, the x value is 2 and the y value is 1. If we choose a point down here, let's do that one over there. This is halfway between negative 1 and negative 2. So this x value is 2, but the y value is halfway between negative 1 and negative 2. So this would be negative 1.5. If we choose another point, the x value here is 2 and the y value is negative 4. So again, we can see a pattern emerging here. The y value is changing every time now, but the x value is staying constant. So we can describe this vertical line as a line where x is always equal to 2. Let's try another one. Let's choose a point here. The x value at this point is -4, and the y value is halfway between 4 and 5, so it's 4.5. If we choose another point, the x value is -4, and the y value is +2. This one here, the x value is -4, and the y value is 0. Last point, let's choose this one. X value is -4, and the y value is halfway between -2 and -3, so it's -2.5. And again, we can see the same pattern emerging. The y values keep changing, but the x value never changes. So this line could best be described as the line where the x value is always equal to -4, because that's the defining characteristic of this line. Regardless of what the y value is, the x value is always -4. So from this, we can see that for a horizontal line, we always have y equals a number as our defining characteristic. And for vertical lines, we always have x equaling a number being our defining characteristic.